Okay, good evening, everyone.
Good evening, sir.
Can someone please confirm if you are able to see my screen?
Yes, sir.
Okay, great. So somebody asked question regarding assignment 1, question number 10. It was relating to Scratch. So let me just open that. Okay, I'll share my window instead of screen. Okay, are you able to see the screen now?
Yes, sir.
Okay, so basically what's happening over here in this question, you're setting so there is a sprite and like object, and then you are trying to set its position to 0 0 initially, and then in this loop you are changing the position of the sprite uh, in x as well as y direction. So in x direction it's moving only one step at a time, and in the y direction it's following a parabolic path. Okay, so what is this parabolic path? So this equation is negative x square plus 17x. So as I showed in the last class, so if you do plot y equal to negative x square plus 17x, so it will be like something like this. So it's a parabola. Okay, let me just bring it back over here. Yeah, so if you see this, so as you increase x, y also increases at till certain point, and then it starts decreasing. Okay, so what is happening in this question? Okay, let me go back to the question. So x is set to 0, y is set to 0. So initially the sprite is at this position 0, comma 0. Okay, I hope you are able to see this. So the sprite is at this position 0, comma 0. Now inside this loop, uh, x is changing by 1 and y is changing by negative x square plus whatever value of x is there. So y will be set to that. So in the first iteration, x will be at position 1. Okay, so x will be over here somewhere. Okay, and then y will be over here somewhere. Then in the second iteration, x will become 2 and y will be somewhere over here. Similarly, in third iteration, x will be 3 and y will be somewhere over here on this curve corresponding to 3. Similarly, in the 18th iteration, x will be set to 18 and y will be set to some value over here on this curve. So that's why the answer to this solution was moves the ball in a parabolic path and stops 18 steps away from the center 0, 0 in x direction. So 0, 0 is the center. In the first iteration, x is becoming 1. In the second iteration, x is becoming 2. In the third iteration, x is becoming 3, and so on. So in the 18th iteration, x will become 18. So in the first iteration, x has moved the sprite has moved one step. In second iteration, it has moved two steps, and in third iteration, it has moved three steps, and so on. Then in the 18th iteration, it has moved 18 steps. So is it clear, Leela, now? If
Sir,
you
it's a 1 minute that scratch codes.
okay,
Sir, actually, in first iteration, x and y value is changing. That is, x is changing to 1, but the movement is, there is no movement. X is at 0 and y is at 0 only at first iteration.
This is at
Only
first.
at second iteration, it is moving to
No,
the
no, no.
current x and y value.
No. So here, if you see this, uh, X and Y, so what's happening? They are supposed to move the sprite here. So they have not written the sprite movement code.
Actually,
So
there is no movement code in the
yes, exactly.
last step. So
Yes.
at
So
the first iteration, x and y is 0, comma 0 only. The ball is standing there only.
yeah, so I see your
So
confusion where it is coming from.
by 18th iteration, x and y value changes to 18, comma minus 18. That is okay, but the movement is in 17 only.
Yeah, so
So
I understand.
17 steps is away.
Yes.
If
So
you try
what's
to,
happening is, I think the question is a bit ambiguous here. So what they are supposed to, what they're trying to ask over here is like, I think at the end of this. So in this question, what?
iteration.
Yeah. So at the end of this entire block, what will be the x and y value? So I
Actually,
think
they
you are
have
seeing
asked
this.
that from center 0, comma 0, how many steps the ball is away means it is 17 steps only away, but the
No,
value
no,
is 18.
no. It's not 17. At the end of this block, it will be 18 steps away. So shall we do it
So
again?
actually, when we run that code, no, sir, at the bottom, x and y directions also it shows. So there it shows that x is 17 and y is 0. So it is moving 17
Okay.
steps away. When
For
we run
okay,
that, it shows that.
let me just quickly do this again. So
Okay.
xy, set x to 0, set y to 0, then there is repeat and repeating 18 times, then set x to x, set y to y. There was a wait over here.
Sir, actually, that set is from motion set, sir. But you have taken from variable.
Oh, yeah. Now I see your confusion where exactly it was. Yeah. Okay. Change x by 1 and change y by 0 minus x square plus 17 into x.
Sir, excuse me, sir. Sir,
Yeah.
before executing, uh, can we take that set to x2 and set to y2 from motion separately and let us see where it at the initial stage, sir?
Where exactly this one?
Yes, sir. That blue two parts alone.
Mhm.
Uh, take another two. So keep it side so that we can check whether set x to 0, set y to 0, where it is showing the position.
Okay. So you want me to set x to 0, set y to
Uh,
0 over here.
so that is separately, not in this code itself. We can keep it separate.
Okay. You
Okay,
mean
so
like
set
over
y
here?
to 0. Ah,
Okay.
yes, sir.
And then you
Now
want me
we
to.
can check this.
Okay. So here x and y are
Sir,
set to 0.
Yes, sir. Yes, sir. Now we can run this code, sir.
I see. So in this case, yes, that is true. So it will be x and y will be at x will be at 17. So let us run this.
Okay, sir.
So yeah, I see your confusion. Earlier, what we were doing, we were trying to set the variable x itself to x, and then that's why. So it was a motion x. In the last session, I just used the variable x as x.
Yes, sir.
Yeah.
Uh, Sir,
So yes,
it's
yes, that
okay.
is true. Yeah.
So
In this
finally, the
case,
17. Uh,
yeah. But if it were like this, if this block, let me just remove this. Sorry.
ah, okay, sir. If it is the moment is at last, then it will be correct.
Then it will be 18. Yeah. So this is, I
Yes, sir.
think, where the
So,
confusion was.
yes, sir. Actually, for the given set, the sprite is 17 steps away from the center only. No, sir, the right answer.
Yeah. That is true.
So for me, that question they have scored 0.
I see. You can raise that issue then there over there.
Sir, I have issued after that result itself from assignment 1. Now assignment 4 also submitted till now. There is no response in discussion forum. Two
No,
times I
if
have
more
posted.
if more number of people, so if it this must be the case with everyone. So if more number of people point this out, so I think they will look into it. So I'm not the person who handles the logistics of the course, but definitely please put it on the forum, and I
Actually,
would
two
ask.
times I have posted. Shall I ask them one more time in discussion forum?
Yes, please, because there's no point actually discussing it here because I can't really help you with that. But yeah, definitely you should put it over there. If
Okay, sir. Thank
yeah,
you. Okay, sir. Thank you, sir.
yeah, thank you for bringing this up. In the last session, I used not the motion set over here.
Yes,
I
sir.
was just
From
setting
there we
X. Yeah, yeah.
yes.
Okay, okay. Yeah, thank you for pointing this out.
Thank you, sir.
Okay, so let us just run this once again. So yeah, so if this were at the end, then it would have been valid that X is 18 steps away from center. But since it is like before this change, so 17 steps ahead is the correct option. Okay, so is this clear to everyone? Yeah, please be on the call. Is everyone there with me on the same page? Okay. Yeah, some of you might be finding it too basic. So as I said, these sessions are meant for those who are finding it difficult to cope with the course. So yeah, so please, you can feel free to leave. It's not mandatory to attend these sessions, but anytime you feel like reviewing any concept, you can come back and view the recordings later at your own convenience. Okay. So yeah, I hope my screen is visible now.
Yes, sir.
Okay. So, hello everyone. For those of you who are joining for the first time, my name is Saish Jaswal, and I'm a PhD student in the Department of Computer Science and Engineering at IIT Madras. And in the last session, we saw some of the concepts. Majorly, we saw lists. In that, we saw 2D lists. We saw nested if condition, nested loops. And then we saw how you can use the nested loops to iterate over 2D lists and do certain operations. And then we went on to seeing NumPy, some applications in NumPy on 2D lists or matrices. And after that, we discussed file handling briefly. We touched upon it. So, are there any queries in these concepts?
Sir, can I ask something?
Yes.
Sir, my name is Shopran Sarkar. I'm from West Bengal. Uh,
Hmm.
I, I I joined the class first time. Uh,
Okay.
I I am asking some my registration process. I am uh, registered in NPTEL swim in last of December, but but cannot complete my registration, and
Okay.
I as a week 1 to 8 as an assignment. Uh, at the yesterday I saw a mail last day of uh, la-
Registration. Okay, I got your point. Yeah, so actually, I think you registered for the course in the last semester, and then you could not complete it that time. Like you could not register for the examination. And this is like the new offering of this course in this semester. So it is mandatory for you to register for this examination in this sem as well separately,
yes,
because yeah, so you cannot continue with your previous offering of the course. So it is mandatory that you should be taking this course, like registering for this course again, and then like completing all the assignments and other things. So yeah, I hope that answers your query.
okay, okay, sir. Can I register this
Yeah,
in
so actually, like these are like some logistics related queries. Sorry. So I would request you to put this on the discussion forum on Swayam portal. So for if you do not know, let me just share this once. So you might be seeing this over here. So in this Swayam portal, there is this Q&A, which if you just go over here, it will take you to a discussion forum wherein you can, like put your queries relating to the course or any other problems you're facing. So please feel free to add your queries here, and the NPTEL team, which takes care of all the logistics, will be able to answer your queries.
okay, sir.
Yeah. So these sessions are actually primarily meant for problem solving and clearing concepts relating to the course. So I may not be able to answer the logistics part of it, but definitely if you have any conceptual questions, please feel free to ask anytime.
Okay, sir.
Yeah,
Thank you.
thank you. Recordings. Okay. So if you go over here to the Swayam portal, you can see here problem solving session, Jan 25. So if you go on this,
Yes, sir.
yeah, and then click over here, it will take you to a Google Sheet in which you will find the links to all the recordings. Otherwise, I'll just share the link to my YouTube channel over here, so you can find all these links there. So I'm uploading all the YouTube channel links over there in this sheet, so you can access it over there.
Okay, sir.
Yeah. Okay. So coming back to the concepts, so are there any queries in the concept that we discussed last time? Okay, great. So in this session, we will primarily focus on dictionaries, like how to create, insert, and delete items from dictionaries. And then we'll go on to seeing try and accept. I'll show you how you can use this for exception handling. Then we'll see some data type in that particularly Boolean. So there are some of the Boolean operators that we did not discuss in Python. So I'll discuss that. I'll also refer to W3 schools for this, and then we'll go on to seeing briefly touch upon Monty Hall problem, what exactly it is, and then we'll see bubble sort, binary search algorithms, and if time permits, I'll also along with bubble sort, discuss selection sort and insertion sort. But although it's not a part of your curriculum, but yeah, it's just some extra information that we'll discuss towards the end of this session. Okay. So far, we have seen different data types. One was int, float. So int is like integer numbers, let's say a equal to 3. Then float is 2.3 or decimal values. Then we had complex numbers like 1 plus 2j. And then we had a string data type, let's say Saish. After that, we saw Boolean data types like true or false. And then we saw lists, which are like collection of different objects or items. So it can be any object, A1, A2, and so on. And then after this, we saw certain operations that were performed on this particular data types. Apart from this, we have also seen uh, NumPy arrays. So arrays are nothing but again collection of numbers. But in that case, you will or any items. But in that case, you can do certain linear algebraic operations using the NumPy library. Okay, so these are different types of uh, data types we saw in the previous sessions. Now, in this session, we are going to see another data type called dictionaries. So, what are dictionaries? So, dictionaries are nothing but a map which maps a key to a value. So, there will be a key value pair, multiple key value pairs in a dictionary. So, let's say, for example, I declare a dictionary called marks. So that is syntax to declare a dictionary is curly braces. I hope you are able to see my screen. Okay. So here, uh, in array, in the case of list, you had this square bracket over here, but in case of dictionary, you'll have curly brace. We'll discuss set and tuple later. So in case of set as well, you will have this kind of curly braces, but there is something else in the dictionary which is not there in the set. So, as I said, there will be a key and a value pair in dictionaries. So, let's say I have a key student one and the marks of the student. So, you can see in the syntax, you have a key here and you have a particular value separated by colon. I can have multiple such key values. Student 2, let's say 60 marks, and student 3, let's say 18 marks. Okay, so there are certain conditions in dictionary. So each key should be unique. You cannot repeat a key in this dictionary. So let me just run this once. So as we saw in the list, so once you declare a list, let me run this once. Okay, it will take some time to connect. Yeah. So you can access elements of list using indexing like 0, 1, 2, numerical indexing. Yeah. So f of 0 will give you A1 and f of 1 will give you A2. Okay. So similar, but in the case of dictionaries, you can access the values using the key as the index. For example, let me just run this marks. So I can access marks of student 2 as, sorry, marks student 2. Let me just print this. So you can see that I need not use that 0, 1, 2 over here. I can use a string key, or this key need not be string always. It can also be an integer or a float or something else. But only condition is that it should be unique. So if you try to do this, let us see what happens. Student 1 and 20. So you can see that the previous value of this student 1 marks got replaced or overwritten by the latest value. So you will have to take care that there are unique keys in this, and you are not overwriting any value over here. So you can see the list of if you want to get the list of all the keys and the values, you can simply use dictionary name dot keys. So you'll get the so even if we declared student 1, 2, 3 and student 1 again, so you will see that there are only 3 unique students in this dictionary. Similarly, if you want to get the values of in this particular dictionary, so you can see that student 1 is corresponding to 20, student 2 to 60 and student 3 to 18. Is it clear so far? Any queries? Okay. And if you want to, get the uh, student like the key value pair, the list of key value pair, so you can use marks dot item. So you can see that it returns you a set of or list of dictionary items. So this is not actually a list. If you want to convert it to actual Python list, you will have to pass it to the list constructor. I'll show you how you can do that. So here it will give you a list which contains tuples. So you can see that there is this parenthesis which contains student 1 and the value. Again, another parenthesis containing the student 2 and the value, and so on. So this is a list of a tuple, and each tuple contains a key and the value, corresponding value. So as I said, like if you want to iterate over, each element in this list, so in this dictionary, so you can get this from marks.keys. Okay. So for student in marks.keys, print student. Okay. So you can access it using the for loop. So this will give you an iterator or a set or a collection of all the key values, sorry, keys, and then you can iterate over that and then print. So if you want to print the marks of that student, so you can just simply use marks and student. So you can also print the marks of the student. And if you want to print specific students' marks, so you can say anytime write marks and then the key value. However, if you try to access as in the list, like if you try to access some element, like let's say I try to access F3, so it will give me an error, index error, list index out of range. So similarly, if you try to access something in the uh, dictionary, let's say student 4, so this will give you key error. So here it was index error in case of list, and here you will see a key error because this particular key is not there in this list. Sorry, dictionary. Okay, so is it clear so far? Any queries, please feel free to ask. Okay. Are there any queries in the chat? We need to know key to get those values, sir. Yes. If you know the key, you can get the corresponding value. But even if you don't know the keys, you can simply iterate over the keys and get the corresponding values. So as I said, uh, you can get the list of keys using this marks.keys or dictionary name dot keys. So if you want to convert that to list, so you can simply use list and pass this marks.key to it. And let me just declare it as marks list. Okay. So you can see now that this operation over here has converted this collection to a list data type, and then you can perform all sorts of list operations, whatever append or something which you want to do. Now, if you want to insert something uh, in the dictionary, actual dictionary, original dictionary, like you have already declared it over here. So if you want the student 4 to be added, so what you can do simply is we can write student max student 4 equal to 49, and let me print max. So you can see that student 4 got added over here. Is it clear?
Yes, sir. Yes, sir.
Okay. Okay, great. Yeah, so this was about inserting an element in a dictionary. You can even insert it in, in a loop. Like let's say for I in range 10. So I want 10 students to be added, and I'm adding some random number marks to the students. So name of a student will be student plus the string value of I, like student 1, 2, 3, 4, and 0, 1, 2, 3, 4. So I can you also do, if you want from 1, I just have to do 1 I plus 1, because the range will give you values from 0 to 9 or n minus 1, whatever value you have over here. Then you can simply write. So let me just declare an empty dictionary over here. Okay, so that I create it freshly. So marks of name equal to let's say I, or I plus 10. Okay, and then I'll print marks. So you can see that as student 1, 10 marks, student 2, 11 marks, student 3, 12 marks, and so on. This was just an application how you can use a for loop to insert elements in the dictionary. You can even read this information from a file. So a file might, so there might be, your data might be in a CSV file or a TSV file. So there are different kinds of file. You can have text file. You can have CSV file. CSV is nothing but comma separated values. So in that you will have like values like, so let's say student 1 followed by the marks of that student. Let's say 20, student 2, and 40, and so on. And the extension of this file will be like file name .csv instead of .txt. Okay. So if you read that CSV, so there are like CSV readers in Python. So you can search about it. Let me just quickly show it to you. So you can go on to any forum, anytime you face any difficulty or have any doubt. So there is a library called CSV in Python, which you can use to read CSV files. Okay. So as we saw in the previous session, like with open file name and the mode, you did not write this mode equal to, you can simply write the parameter over here as file. So you are creating a CSV reader here and passing this file to it to get the data from the CSV file. And then you can print every, each line in that CSV or do certain operations using this CSV library. So this was just an introduction. I'm not sure if you have this in the course. I don't think so. It's there now at this point. But this is just for your information that there is something called as CSV, which we might use later in when we touch upon pandas library. So there is a library called pandas, which you can use to create tables, table of information. So we'll look into it later. But for the time being, just remember that there is a library called CSV which you can use to read data from CSV files. So coming back to, yeah, dictionary. So what I was talking about is you might have data stored in a CSV file or TSV file, which is tab separated file values. Instead of comma, you will have tab over there. And then you may even have another data type in Python. Let's say you have two lists. List one of students, S1, S2, S3, and so on. And list two of their marks, sorry, 12, 54, 67. So you can iterate over this list and create a dictionary. So for example, let's say marks. So for I in range, can anyone tell how how I can iterate? So how will I get the number of iterations from this information, whatever information I have just now? So I have declared these two lists. So I want to iterate over each item in list one and create a dictionary such that S1 will correspond to 12, S2 will correspond to 54, S3 will correspond to 67. You can unmute and answer or write it in chat. So what will I write in this range over here? For I in range, obviously.
List
So,
one,
oh,
sir.
sorry,
List one, sir.
no. If you put range expects what? Range expects
Sir,
something
I
integer.
think it's sir, I think it's len function.
Yes, that's correct. So for I in range, len of list one, not list one. Okay. So it will take the length of this list. So you'll have to ensure that list one and list two are of same length. Then you can do marks of list one of I equal to list two of I. And let me print marks here. So you can see you have used two lists to create a dictionary. You can even, like even if you don't declare this, it will still work because it creates a dictionary by default. As soon as you kind of try to use this kind of like statement over here, marks of like dictionary name and some key and some value. Is it clear, everyone?
Yes, sir.
Okay, please feel free to ask. If it is not, I'll repeat and explain it again. Okay, so this was about inserting elements in list. Sorry, dictionary. What about deleting? So in the case of list, you had this option remove or pop. Whereas in dictionary, you'll have this operator called del. So if you want to remove something, so you can simply use del marks of S1, sorry, and the key. And let me print marks. So you can see S1 is removed from this dictionary. The key S1 and the corresponding value of S1. Okay. So this was about creating dictionary, inserting some element into dictionary, and uh, deleting an element in dictionary. Let us see if you have missed anything from the dictionary concept. So we'll go to the W3 school, Python, and you can find dictionaries somewhere over here. Yeah, here it is. So this is an example dictionary, this dictionary. So you have, so you can even have it on multiple lines like this, which will make it clearer. Like if you declare it like this, so you have a brand, the value is Ford, you have model, some value over here, and year, and some corresponding value. Okay, then let us see. Yeah, so you can access any element or value corresponding to key using the dictionary name, square bracket, and so you'll have to be very careful. So dictionary is declared with curly braces, but to access elements, you'll have to use square bracket as you use in the list. Okay. Regarding this ordered and unordered, so dictionaries, so if you have a specific index, assigned to, or like there is an order of the elements, so the data or the object, collection object, it's called ordered. So dictionaries are ordered, lists are ordered because you can access, list element with the indexing 0, 1, 2. Similarly, you can access the dictionary items with some key values. Even if you use this, let me share this once. Marks of 0. If you just do this, although it is dictionary, it will give you, sorry, let me check if this works. Okay, it doesn't work in Python. Yeah, sorry, my bad. So I thought like it will give you, the first key, but it doesn't work over here. Yeah. So where were we? Yeah. So ordered list, sorry, ordered and unordered objects. So dictionaries are ordered, but when we will see set in Python, so sets are actually unordered collections. We'll discuss this in detail later when we'll touch upon set. We'll have tuple as well or tuple. Then changeable dictionaries you can change. So you can, as I said earlier, sorry, I was not sharing this screen. So dictionary values can be changed. For example, as we saw over here. So there was the student 1 50, student 2 60, student 3 18, and student 1 20. When I did this, the value got updated with the latest assignment here. Similarly, I have this max now. Sorry. So I have this max, and if I do mark of S2 equal to, let's say, 60, and then print marks again. So you can see that the value in this particular section, like for student 2, got updated. So you can update, you know, like the values corresponding to a key. So dictionaries are changeable, or you can also say this mutable. Sorry. So we'll see this in further detail later when we'll discuss tuple, because tuples are not changeable or mutable, or they are immutable. Because you cannot change, once a tuple is declared, you cannot change the values in the tuple. We'll come to that when we'll discuss tuple. So this is just for your information. Yeah. And as we discussed, duplicates are not allowed in uh, dictionary. So if you declare it twice, some key and value, so the latest one will be taken into account. Similar to length of list, you can also get the length of dictionary. This will give you the number of key value pairs you have in the dictionary. So for example, len of max will give you the number of key value pairs over here. Okay, so you can have any data type as key. In this case, you have a string over here. Here it is a boolean. Here it is a integer value, and you can even have a list. And even you can have a nested dictionary inside a dictionary. So for example, let me show you this. Okay, so I have, let's say, students. Let me think of some example. Or let's say some random dictionary. So I have a key, and I can have another dictionary inside this, which will have its own set of key value pairs. Let's say 1, D, 2, and so on. And if I try to access the first element, it will give me another dictionary. And then in that, it will give me like this dictionary will give me this dictionary. Like this access will give me this dictionary. And then I'm trying to access another element in that dictionary. So is this part clear? Like the nested dictionaries? Anyone? Yes, no? Any answer?
Yes, sir.
Okay, great. So let us go back to W3 school. Yeah, so you can ignore this for the time being. So as we saw in the case of list, we won't go into class because it comes under the topic of object-oriented programming, which is outside the scope of this course. So it's not discussed here. But if you see the type of, let's say list one, you will see list over here. And if you put type of dict one, so you'll see dictionary here. So this particular variable is having the type dict, and this is having the type list, list one, list two, and so on. Okay, yeah. Similarly, there is another. So you need to know some basics of object-oriented programming. So this constructor is a concept from oops, uh, object-oriented programming concepts. So you can declare a dictionary like the way we use the curly braces. You can even use the DICT like constructor, the way we use this list constructor, or numpy array constructor. So if we had So we were like in case of NumPy, import NumPy as NP, and then we had let's say list, or let's say a vector, 1, 2, 3, 4, and I want to convert it to an array. So vector array. So I can simply pass it into np.array constructor, and let me just print the types of this too. So you can see that the type of the first variable is list, and type of another variable vector array is numpy.ndarray and dimensional array. Okay, so this is nothing but you're calling constructor of a class np odd array, and in this case you're calling constructor of class. Like if you are just want to convert something to some other data type, you call the constructor of that class and then pass on the values over here. Similarly, like you do typecasting like int and then you pass on some value over here. So that is also like you're calling the constructor of class int and so on. So don't be so confused with the constructor concept. It is something relating to object-oriented programming. So it's not in your curriculum. So you can avoid this part. Okay. So this was all about dictionaries. So let me go back to the slides and see what all concepts are there. Yeah. So we saw dictionaries. Then I'll move on to try except. Before that, I would like to discuss the operators first, booleans, and then we'll see try except later. So again, let me go back to W3 schools and then we'll see all sets of operators. There are certain operators which you may not be needing now in this course, but we'll just quickly discuss what all operators are available in Python. There are certain operators which even I don't use as such, so we'll skip them for the time being. Okay, so these are the basic operators: addition, subtraction, multiplication, division that we have already seen. Modulus is something which we have seen earlier in case of Scratch as well. So let me go to Scratch. So there was this mod operator over here in Scratch. So this gives you the remainder of the division. So if x is divided by y, whatever is the remainder, that will be your modulo. So let me share this again. Then you have exponentiation. So if you have x double star y, so let's say x equal to 2. Yes, Leela, you can merge two dictionaries. But I think that is one of the questions in your assignment as well. And then if let me print x. So it's 2 to the power 3 or 2 cube 8. But if you do this, this is not 2x to the power y. So we generally use this cat in mathematics or like in just notation to denote power. But in case of Python, it's not power, it's exponentiation. It's not exponentiation, it's bitwise XOR. So we'll discuss that shortly. But be careful that this is not a power operation like or exponent. So double star is exponent. If you use single star, it's simple multiplication, x into y. And if it is double star, so it's x power y. or x raised to y. Then you have floor division. So we have discussed this as well, but let me quickly touch upon it. So let's say you have 20 here and 3. So x divided by 20, sorry, 20 divided by x divided by y, 20 divided by 3 will be 6.66 something. But if you do double slash here instead of single slash, so you'll see that it will give you the integer part of the division. So this is 6.66 and so on. However, if you just divide it, like if you do the floor division, it will give you the floor value of the uh, division operation. Okay. And then these are some of the operators, assignment operators that we'll discuss. So these are quite useful in programming. So equal to is something which we have used a lot. We'll discuss the complexity involved over here as well. Like we'll see the identity operator later. And then there is this plus equal to. So we generally write this for those of you who are new to programming, uh, x equal to x plus 1 and print x. So x had a value of 20 and I have changed x by x plus 1. So it has overwritten the value of x. You can write this same thing as x plus equal to 1 and let me print the value of x. So it does the same operation as this x equal to x plus 1. It's just a shorter way of writing this. Okay, similarly for other operators as well. So you have x plus equal to minus equal to into like asterisk equal to, which will do the multiplication, division, modulo, floor division, exponent, and so on. Okay, we'll discuss this later, like what these operators are. Uh, all these operators, these are like bitwise operators. So we'll come to that shortly. Okay, so is this clear so far? All these operators?
So,
Yes, Pawan, that is also possible. You can sort the dictionary, and you can arrange uh, the dictionary keys based on the values. So that is possible. But you'll have to think over the logic, how that can be done. Okay. So then we have comparison operator. So what we saw here, like some basic arithmetic operators, some assignment operators, and then the comparison operators. So you have this equal to, so it checks if x is equal to y, it checks only the value, you know, and not equal to. So this will be true only when x is not equal to y. So let me go over here. Sorry. So x equal to y. So this will give me false because x is 22 now and y is 3. And x not equal to y will be true because x is not equal to y. Similarly, you have this greater than operator, less than operator, greater than equal to operator, and less than equal to operator. Now, we saw in Scratch, like we discussed some basic Boolean algebra and or and not. So here they are. So in Scratch, we saw there these three operations and, or, and not. So and will be true when both of the conditions are true. If any one of the condition is false, then the complete solution or like the result of this AND operation will be false. Similarly, OR will be true when at least one of the conditions is true. Like either both can be true or one of them can be true. So this will result in true. However, if both are false, then OR also will result in OR operation will also result in false. Similarly, and then there is this not. So if something is true, it will just reverse it and make it false. Another way around. So and operator, it returns true if both statements are true. For example, x is less than 5 and x is less than 10. So if both of these statements are true, then this will return true, else it will be false. Or returns true if one of the statements is true. And then not will reverse the result. Whatever result you have here, it will just uh, reverse it simply. Then there is this identity operator. So before moving into that, is it clear so far? Okay. Yeah. So it might be like information overdose. So please bear with me. Like you can, once you practice this, you'll get used to it. So you need not remember everything. Even I don't remember every single syntax in Python. Uh, you make mistakes and you learn. So even if you don't know, you can simply go and search online and uh, revise any concepts. So you did not bother about knowing every single thing in Python. Yeah, but from the exam point of view, you should be knowing some basic things which are needed. So the course doesn't ask you to remember every single thing. It will give you certain things which are like most frequently used. So whatever lectures you go through, you'll see that the TAs might be using some of this syntax over there, not all. So you are expected to, use them and remember them for from exam point of view. But in general, it's not necessary that you remember every single syntax in Python or any programming language in general. Okay, so now coming to identity operator. So we saw this assignment operator or comparison operator in which we had this equal to, which compares the value. Okay. Now we will see something interesting in Python. So returns true if both variables are the same object. Okay. So let us go back to Python. Um, Let me write it as use case of identity operator. Let's say A equal to 2, B equal to 3, and C equal to A. Also, let me make it AB equal to 2. So what will be the result of A equal to B? It's true because the values of A and B are 2. Okay, let me zoom it in. However, if you do A is true, sorry, yeah, let us see this example over here. This is better. So X is an object list, Y is a list, and Z is pointing to X. Let me just copy this to the collab. Okay, so X is a list, Y is a list, both are identical, and Z is equal to X. So now printing X is Z. So this will return true because Z is the same object as X. Okay, so let me run this once. So what is happening over here? So once you assign a list object to another variable, this particular variable Z also points out to X. So let me print this Z, sorry. So Z is having the values of x. But what if I change something here? C dot append mango. So z is having this, and let me print x now. So can you see this? What's happening over here? Since z is assigned x, it's actually z is pointing to x. And once you change the value of z over here, like I'm appending something to z, so you can see the value of x is also getting changed. So these two are the same object. So this x is stored in some space in memory, and z is simply pointing out to x the moment you assign this over here. I'll show you something interesting uh, shortly. So here, what is happening with this identity operator? X is z. So this will see if x and z are pointing to the same object, or are the same object. And in this case, x is y. So in this case, it is different because x is a different object and y is assigned a different space. And but however, if you do x equal to y, this will be true because both are having same values. So equals to means double equals to operator here. It compares only the values and returns true if both the values are same. However, this is operator will return true only if the two objects are the same. Is it clear, everyone? What these identity operators are? Yes. So X will be assigned some memory in the space in your storage. So once you do Z equal to X, Z simply just points to the X. However, if you do X dot copy, I'm not sure. Just a second. Let me just search this out. So I don't remember the syntax. So copy an object. So it's okay. It's simply copy. Yeah. So x dot copy. If I do, and let us try this out. So now you can see x is z. It's not true because it's creating a copy of x and then storing it in z. So z is being assigned another space now in memory. However, if you just simply use, and now if you change the value of z, let's say, and then print the value of x. So you can see that both are not getting affected. I mean, say x is not getting affected because of z. Because in this case, z is assigned some other memory location. Is it clear, Deepika? Okay, great. Yeah, by the way, like all these concepts may not be discussed in your uh, actual lectures, but this is just for your information. So if you want to use it somewhere else, you can later. Okay, so this was about this copying and the identity operator. Let us quickly go on to the other operators and then we'll see something else in Python. And we'll quickly touch upon the concepts of uh, Monty Hall problem and the binary search and sorting algorithms. Okay, similarly, is not returns true if both variables are not the same object. So it's nothing but simply the not operation on this is. And then membership operators we have already seen in list and in any you can use it in string as well. So if something x in y will return true if x is contained in y. So if it's a substring and then it's a string, then if that substring is in a string, then it will be true. Similarly, if there is some element item and then there is a list here, so if that item is there in the list, so it will be true, and so on. Similarly, this not in is nothing but like not operation on this x in y. Now this is something new, bitwise operator. So as you know that the computer understands only binary language, that is the language of zeros and ones. So the number 6 here. So I assume many of you know the binary number system. If not, please excuse me for the time being. So I don't want to confuse you, but so here 6 is represented in a binary number system. So this represents 2 to the power 0 position. This is 2 to the power 1 position, 2 to the power 2, 2 to the power 3, 4, so on. So 0 into 2 to the power 0 plus 1 into 2 to the power 1 plus 1 into 2 to the power 2 will give me 6. These are all 0. So higher powers are, so these are nothing but like coefficients of this powers of 2. So if it was like just, you know, 0, 0, 1, which means it is 1. If it is 0, 1, 0, it is 2. It is 1, 0, 0, it is 4, and so on. So if you have two numbers, 6 and 3, so this is like the corresponding binary representation of 6. This is the corresponding binary representation of 3. So if you do bitwise, so there is this operator called bitwise AND operator. So it will take every bit position and do the AND operation on each bit. So 0 and 1 will be 0, 1 and 1 will be 1, 1 and 0 will be 0, and all these are 0 anyway, so this will be 0. Okay. So they have given this example also, like 0 is this, 1 is this, 2 is this, 3 is this, and so on. So if you do this AND operator, bitwise AND, so it will do, you know, uh, bit by bit AND operation here. Similarly, there is this bitwise OR and bitwise XOR. XOR is something which we did not discuss earlier. For those of you who do not know, let me just quickly show XOR operation. So in the case of uh, OR operation and AND operation, we saw that AND will be true only if both are true, and OR will be true if at least one is true. However, XOR will be true when only one of the inputs is true, or there are like odd number of ones over here. Sorry, zeros here. So 0 and 0, 0 XOR 0 will be 0. 1 XOR 1 will also be 0. However, 1 XOR 0 or 0 XOR 1 will be 1. So in this case, if you were to do OR operation here, so it would have been 1, but in XOR, it's 0. Okay. So yeah, this was about the Boolean operators we have. So as I said earlier, this cap over here, it's not, you know, the exponent, but the bitwise XOR operator. So you can see here, there is this 6 and 3. So 0 XOR 1 will be 1, 1 XOR 1 will be 0, 1 XOR 0 will be 1, and so on. So this will give me some number, 5. So 6 to the power 3 will be something else. It's 2 and 6, I think. And then 6 bitwise XOR 3 is 5. Is it clear, everyone?
Yes, sir.
Okay. And then there is this zero fill left shift and right shift. These are also by bitwise operators. So it will just simply shift this, number digits by left. Like if you do this two times, so shift three, the digits in three, two by two positions. So it will simply shift this one by two positions here, like each digit by two, and then the ones at the end will be falling off, and the zeros will be appended at the end. So this is actually used in some competitive programming um, problems. Like if you have to multiply something by two. So let's say you have this number. So this represents one. So you want to, multiply each by two. So you can simply, do this left shift so that this bit will shift to the right, sorry, and this will becomes 2. Similarly, this will be 2 power 2 and so on. So um, you will see this application later, but this was just one of the applications that you can, do exponentiation using this shifting operation. Similarly, there is this right shift, which is like equivalent to dividing by 2 as well, shifting the bits towards the right. Then you have operator precedence at the Bodmas rule that you already must be aware of. So in programming languages also there are certain operator precedences. So certain operators are given more precedence than the other operators. So in this case, 100 plus 5 into 3 will evaluate 5 into 3 plus first and then do the addition operation, even though some plus is written before. So it follows the rules of mathematics plus some programming rules over here. So in this case, like you have more preference, parenthesis has more preference, then after that followed by exponentiation, and then followed by, unary and so on. So you can look into it later. So this was all about the operators. So are there any queries in this operator concept? Everything clear? Okay, what did you not understand, Leela?
Sir, no, sir. You asked whether any query. I said no.
Okay, okay, got it. Fine. So this was about the operators, and in operators we saw Boolean operators as well today. Now let us go on to seeing try except. So as we saw earlier, like we were trying to access something over here, like some random element in the list, which at which index at this index there was no element uh, existing. So it ended up giving us index error. So in such cases, like if you have a long 1,000 line code and you don't want the code to stop abruptly at certain point. So in that case, you can use something called as exception handling or try catch block in Python. So let me switch to W3 School again. So in Python, it's called try except. I think in Java, it's called try catch. I don't remember exactly in C or Java. So yeah, so in Python, it's try, except, else, and finally. So let me just show you this example. So we are uh, writing some code inside this try block. Okay, let us go to collab. So I'm trying to print x, let's say x1. We don't have this variable x1 declared. And let me, before doing this, let me just try printing it here. So you'll see that there is this name error. because the variable x1 is not declared at all. If you try to access a list element which does not exist, or like some index which does not exist, so you will get that index error. In dictionary, you will get key error if you try to access some dictionary element with a key which is not present in the dictionary. And then in the case of variables, like if the variable is not present, you will get this name error. So I don't want this, issue to occur. Like there is some other important code that runs later, which may not be dependent on x1, but you want to run this irrespective of what the value of x1 is. In that case, it is good to have this try except block. So you print, you let me run this, and let me also write something here. I am here. So if I were to write like this here and run this, so you can see that the code just stopped here. It didn't move ahead. So name x1 is not defined, and then the later code was not executed. However, if I do this, try except, so it will raise an error here. And then as soon as the error is raised, it will go into this except block and print the whatever message you want to print or whatever operation you want to do here. You can write another set of code, piece of code over here, and then it will come out of this and then do your other operations uh, as it is. So let me now declare x1, x1 equal to 2. So in this case, it is printing x1 and then not going to this except and then just going over here outside and printing I am here. So this is about try except exception handling, basic exception handling in Python, which you can use in your codes if you're writing like, very long codes like thousands of 2000s of lines of codes. In that case, it's very important, to do this exception handling to stop your code getting stopped abruptly or prevent it from stopping abruptly. Okay. Similarly, you can even, so as you saw, so it gave name error. So if the exception is of the type name error, it will print that particular exception message, like whatever you want to give. Else, if it is of some other type, you will get some other error message. So this can also be used, to debug your code. So at certain point, you just forgot to declare a variable. So you will get a variable x is not defined. So if it is a name error, if it is an index error, you can also write like except index error. And then you will get to know that you are going out of the index. Like you are trying to access some list element, which is out of the index. So it all depends. Like you can have multiple such excepts with the actual exception name which you are aware of, and during the runtime you want to just analyze like if what kind of errors the code is uh, having. Then there is this else, as we saw in if else. So it will uh, if there were no errors, so it will just print something and then go on to the else part. This is equivalent to not writing else and then just writing this print outside of this block. Okay, but in that case, the only change is that it will not print this if there is some exception, like there is some exception and you don't want to execute the later code, so you can put it in the else block. So if you put this print outside over here without else, so it will anyway print that, irrespective of this having any error or not. But however, if there is an error, it will go into this except and then come out of it. It will not execute this else block over here. Then there is this finally, uh, as we discussed earlier, like irrespective of whether the exception is generated or not, this finally block will always be executed. Okay, so there are some examples here. You can even raise an exception. So like if x is less than 0, in this case, like you can use this keyword called raise and then a function exception, and then just put a message over there that x is less than 0 and this is an exception, so I'm just raising it, and then you will get an error over there. So you can put the other part of the code in try catch. So let me just run this. So you can see there is this exception, sorry, no numbers below zeros, something like that. So this is just an example wherein you can explicitly raise an exception. In this case, when you are trying to access a variable without any name, like declaration, so it was throwing an error or exception by default. But if you want to do on checking after checking certain condition on a certain variable, you want to raise some exception. So you can do that using this raise operator over here. Okay, so this was so you can see that these are like all bite-sized tutorials on different concepts. So you can anytime if you feel like you want to revise something, so you can definitely go over here and like try to brush up the concepts. So this was all about exception handling. Okay, so somebody mentioned about bitwise shift. Please explain once again. So bitwise shift, Ravindra, is nothing but shifting the bit values. So let me go back to operator. So you have this number 3, and 3 is represented as this in binary number system. So when you do shift by 2, it will shift each bit by 2 positions. So this bit is shifted by 2 positions. The second bit is also shifted by 2 positions. So the end result will be this. So both these are shifted by 2, and then you have this 0 getting appended at the end. So that's the only use of this bitwise operator. Let me just try 3 here and run this. So you'll see 24 here because 24 uh, will be like this. So I have shifted this by 3, 3. So this is 2 power 0, 2 power 1, 2 power 2, 2 power 3, which is 8, and 2 power 4, which is 16. So 16 plus 8 is 24. Oops, sorry, the screen was not shared. My bad. Yeah, I was trying to explain this. Sorry for that. So there is this 3 over here in binary number system. So if I do shift by 2, so this element, the bits over here, the ones, are getting shifted to the left. This is the left shift operator. So the resultant number is 12 over here. If I shift it by 3, so each bit will shift by 3 and then the zeros will get appended towards it, towards the end here. So this number is 24 because it's like 2 to the power 3 plus 2 to the power 4, which is 8 plus 16. Is it clear, Ravindra? Okay, great. And Karthik, about your doubt, when there is no error, will it work? Yeah, so if there is no error in the try except block, so it will still work. It will just execute the code in the try block and then go on to the next part. So it will simply execute as we saw over here as well. So we declared x1 and then tried to print something over here. So there was no error. So it just printed the value of x and then come out of the block and then printed I am here. Is it clear, Karthik? Okay, Lida, what is the use of finally? Anyhow, it is going to print the content through it, though it is given outside finally. Yeah, so that's a syntax in Python, like associated with. Okay, let me see the use case of it. So this is equivalent to like, not writing anything over here and then uh, executing something. However, let me just run this. So if x1 was not declared, so it will, in this case, it will throw an error and then execute this. So there is as such nothing important. This is equivalent to doing this. Oops, sorry. So irrespective of what's happening here, uh, let's say x1 equal to 2, this will also do the same job. But this is that's just some syntactic sugar that they have added that if you want to, have this try except, you will have this finally as well, which will execute anything irrespective of the conditions. And if it were else, so it will only execute uh, only if there is this, let's say, I. Okay, so when this is true, if it is not true, means if there is an error, sorry, okay, let me just restart the runtime, or let me just take the example from there. It will be better. Okay, so if there is no error as such, then in that case, this particular else will execute. If there is some error, it will go to the except and then come out of this. So in that case, else will not be executed. In this example, I think the x1 was already declared in our case. That's why that error didn't occur, and it went on to this high because this exception was not raised. But in
Name of
certain case,
screen was not there.
oops, sorry.
Excuse me.
Let me make it x2. So you can see over here, an exception was raised, and this was not executed, and then it went outside. Is it clear? The use case of else, Leela?
Yes, sir.
Okay, great. So let us quickly wrap it up. We have Monty Hall problem and bubble sort algo and binary search. So to explain Monty Hall, let me just quickly join from my iPad and then I'll try to explain what exactly this problem is. Please be there on the call. Okay, are you guys able to see my iPad screen now?
Yes, sir.
Okay, great. So, what Monty Hall problem is, you would have also looked into the lecture. So, let me just quickly talk about it. Let's say sorry, you have three doors. and behind one of the doors is your reward. Let's say a car, and then behind the other two doors is are goats. So you are given a chance to select any one of these doors, and then once you select, let's say you select two, and forget about this car goat. So there might be car in any one of this you know behind any one of these doors. So probability of getting a car is 1 by 3 for each of the doors. You agree with this? I think okay, let me stop share here. Is it visible now? Okay, is it visible now? Okay, great. So what I was saying is, let's say you have three doors, three random doors, and then there is a car uh, behind one of these doors, and goats are there behind the other doors, all the other doors. So the probability of getting car from uh, by selecting one of these door randomly is 1 by 3. It's equally probable. So I select this one door, let's say 2. Now the host as opens another door which contains goat. Let's say door number 1. So it has, let's say, goat, and car is there in one of this uh, two uh, behind one of these two doors. So the problem over here is that if you switch, like if you stay with this option, so the host will give you an option whether you want to continue with the current door that you have selected, let's say door 2, or you want to go and switch the door. So uh, in this case, what do you think, like whether staying with the same door or switching the door will give you higher chances of getting a car? It's a question. Yeah. So what is the mathematical reason behind that? Like why switching helps? It may not always, give you uh, the car. The car might still be behind door 2, but if you do it multiple number of times, like if you do multiple experiments on an average, you know, so what's happening over here? So let's say the probability of, getting car from this door is 1 by 3, and getting car it from every other door is, 2 by 3. So as soon as the host says that the goat, this behind this particular door, there is a goat, so the probability shifts or gets concentrated on the remaining door. Okay, so that's why you get higher chances of uh, getting a car behind the other door if you swap or switch. This will be clearer. Let's say you have, sorry, 1000 such doors. So the probability of getting a car in behind each one of these door is 1 by 1000. Now the host asks you like which door you want to select, and you select some, let's say, 99th door. And now the host opens the rest 998 doors, and one door is kept closed. So then you will have like the probability, which is 998 by 1000 will be concentrated on that remaining door which was not open. So let's say this all these doors were open and then each one of them had goat behind them and you had only two door, either 99th or some door X. So if you switch on to X, you have higher probability of getting a car than staying on the same door. So that's the basic mathematical principle behind this Monty Hall problem that was discussed in the lecture. So if you get any concept or conceptual question uh, on whether switching helps or not, so yes, it definitely, but it will not guarantee you uh, that there will be a car if you switch because the probability is still 2 by 3. Means in case of three doors, it's still 2 by 3 and there is still 1 by 3 probability that the car might be in behind the door too. On average, if you do this experiment multiple number of times, switching will definitely help you out. So this was the basic concept of Monty Hall problem. So I hope this is clear. We'll go on to the sorting part. So let me share my screen again. Okay. So we saw dictionaries, try except some operators, including Boolean operators, and then Monty Hall problem. Then we are left with bubble sort and binary search. Okay, so let me use my iPad again for this. Okay, so let's say you have been given some numbers 2, 5, 1, or let me start with some 5, 2, 1, 3, 4. And now you want to sort these numbers. One simple thing is means you can definitely see it and sort it. But computer sees the numbers one at a time. Okay. So it doesn't know like when the index is over here, like the pointer is over here on this. It doesn't know what is there beyond this. So how will you do this? So there is an algorithm called bubble sort. So I'll show you why it is called bubble. Okay. So what it does, first of all, it takes two numbers, sees if they are in the correct order. So if you want to sort it in ascending order or descending order. So let's say we want to sort the given list in ascending order. See, it sees this two number at a time. Means one variable has this number, other variable has this number. Is this in the correct order? It is not. So it will swap this and then keep it keep it as it is. Keep the rest as it is. Then it will move on to the next position and see if the numbers are in correct order. They are not, so it will swap. Now it will move ahead and check if the numbers are in correct order. They are not, so it will stop. And finally, it has come to the end and the numbers are not in sorted order, so it will swap. So if you see it this way, sorry, let's say this was vertical. Like if you are seeing it from this way, you see that this number 5, it kind of like floats like a bubble uh, towards the end. Okay, that's why it's called bubble sort. because it each either you want to do you know ascending order sorting or descending order sorting. So in that case, you will be swapping it the other way around. Like if you want it to be ascending order, so you are trying to push all these largest numbers or larger numbers towards the right. So you see that this 5 floats like a bubble towards the end. Now once you have this list, 2, 1, 3, 4, 5, 2, 1, 3, 4, 5. So at the end of this one iteration, you are sure that the largest element is towards the end. Now you are left with only this part of the list. So now you are here. You see if this is in the correct position, if the numbers no, then swap them. 5 is untouched. Now 2, 3, correct. Okay. 3, 4, correct. This is also okay. And you stop. Okay. So this was like a basic uh, bubble sort algorithm. So if the moment you see any numbers in unsorted order or not in the correct order, you swap them at that position and then move ahead. And then that will ensure that the largest values will be accumulated towards the end. So this was a mini example of bubble sort. Let me show you an animation like a bubble sort online. So there are other sorting algorithms like selection sort and insertion sort. We'll see some animation for that as well. Okay, I hope you guys are able to see the screen. Okay, so these are the numbers. You can see not in correct order, swap, correct order, okay, not in correct order, swap, and then not in correct order, swap. Now going back again to the first. Now there is a wall here. So this is sorted already. Now not in correct order, it's in correct order, not in correct order, swap, not in correct order, swap. Now the wall has shifted. Now again, not in correct order, swap, not in correct order, swap. And again, the largest of these four values is towards the end. And then so on. It repeats. The wall has shifted. And then towards the end, it swaps 14 and 18. And it's sorted. Is it clear, everyone, how it works?
Yes, sir.
Yes, sir.
Okay. So the loop will stop when you are, the at towards the end, like last two elements are there. So you will have to like write a nested loop to access you to go over all the elements. Like the first loop will go on all the elements till the last second, and then the inner loop will go on the sorry, the first loop will go till the last, and then the inner will go accordingly. The way you are moving this particular box over here. So one was index I, the other was index J. So you will have to move the index accordingly, I and J, and then swap the positions and then uh, move on. So yeah, I'll recommend you think over it, like how you can solve it yourself. Don't look at the solution right away. Try writing it on your paper and then see how it works. Even if it is a pseudocode, that should be fine. So by the way, for those of you who do not know what pseudocode is, so pseudocode is nothing but writing a program in simple English, like initialize x to 0, then initialize y to 0, and so on. You can write the steps So this is nothing but a pseudo code. It's not a code with using the syntax of Python, but it will give you an idea like how the algorithm works. So you can write a pseudo code first and see how it works. Okay, this was about, and there are other sorting algorithms, but in interest of time, I'll just quickly show you. So selection sort. Oops, sorry.
Hey everyone, it's me again, and in this video I'm going to
Okay.
explain the selection so you will and we for very fairly that we'll have and we'll
So what happens here? So in selection sort, it goes on to finding the minimum element in the list and it moves it to the beginning. Then again, this ensures that the minimum element is at towards the front. Now you have this remaining list. So you go on to finding the minimum element in this list, and once you have the minimum element, you shift all the elements to the right, and then insert this minimum element over here.
clear min is we just create it some temporary
So
shelter,
let me see
take
a good
2,
animation
place
for
it
this.
within.
Okay, so 2, 4, 1, and so on. 1 is the minimum. You then just simply swap this. Okay. Okay, that is in the other sorting part, like when you shift it. So I'll come to that as well. Insertion sort. So this is the selection sort. So you see the minimum element. In this, minimum element is 2. So you swap with that. Now in this case, 3 is the minimum element. So it will find 3 and then swap it with 4. Now 4 is the minimum and so on. So you select the minimum and put it in the correct position. That is the basis of this selection sort algorithm. Unlike the bubble sort, wherein at every step you are just checking like whether it is in the correct position or not. In selection sort, you uh, go on over the entire list, remaining list, take the minimum element, and then replace the uh, current element with the minimum element, and so on. There is insertion sort. There are other sorting algorithms like merge sort and quick sort, which you can look into the details of them later. Okay. So here you can see that it sees if it is in the correct order. The moment it finds that the order is not correct, so it will keep on pushing this till the time you get in the correct order. So 3 is over here, so it will push till 2. Okay, 11, 9 will come to its position, 5 will come till 4, and then 7 will come till 6. So this is insertion sort. So did you get the difference between bubble sort, selection sort, and insertion sort? You can go over it later as well. Okay. Yeah. So this was the basis of these three sorting algorithms. So why did we discuss sorting first? Because we want to go on to a searching algorithm called binary search. Okay. So let me share my iPad screen again and explain basics of searching. Okay. So let's say you have a list 2, 5, 6, 1, 9, 21, 13. Okay. And you want to search, let's say, an element 1, if it is there in the list or not. So, what is the basic way you can do that? You will first go on to 2, see, compare if 2 is equal to 1, no. Then go on to 5, compare, it's not equal. Go on to 6, compare, it's not equal. Go on to 1, and then compare, yes, it is equal. And then you will return the index. Okay, so if it were not there, let's say you want to find like element 3. So you will just go on and you have reached the end of the list, and then you will say that this element is not present in the list. So this is the linear search that you are doing. So the problem over here is that you will have to go over every single element in the list, even if you know uh, uh, that number is like greater than or smaller than the given number. However, what if you have this list in sorted order? Let me give you an example. So you have a telephone directory or dictionary, let's say, the actual, not this Python dictionary, but the actual dictionary, the Oxford dictionary or whatever dictionary you use. So if you want to find a word, let's say it starts with C. So you know that the dictionary is sorted based on the alphabetical order, like A, B, C, D, and so on. So what you will do, you'll randomly open a page. You will see if it is, let's say these are all pages. You have letters starting with words starting with A, words starting with B, words starting with C, and words starting with D. And there are multiple such pages. You randomly open some page. Let's say you land over here on words starting with D. So you know that words starting with C will only be before this word starting with D because it is sorted. You don't have to look into the other part of the dictionary. Okay. So what you did, you randomly opened a page and then you know that the element that you're looking for or the word that you're looking for is in this part of the list, this blue part of the list. So your search space is reduced now. And now you go on to the random page. Let's say you go over here. Now you land up on the page uh, which has like, word starting with B. So you know that the word starting with C will be only after this particular part. So now your search space is further reduced. So you only have to search only in this area and so on. So you keep on reducing the search space and then finally you land up on that word. So if provided that word exists in that list. Okay. So that is the major, that is the basic, that is the basis of this binary search algorithm. So what it does, let's say you have this. So the basic requirement for binary search is that the list should be in sorted order. So we'll have to first sort it out. Let's say 1, 2, 5, 6, 9, 13, and 21. Now, how many elements are there? There are 7 elements. So what it does, it goes on to the middle element first. Let's say you want to search 2. It goes on to the middle element, then it compares whether 2 is smaller than or greater than 6. So it's smaller than 6, so it will search in this part of the list. Then again, it will go to the middle of it. So there is nothing as such in the middle, so it will either take this or this. It depends on your algorithm. So let's say your pointer lands on 5. So in this case, it will again compare whether 2 is less than or greater than. So it's less than, so it will just look into this particular list. Now it will go to the middle one and then compare. It is equal to 2, then it will just say the element is found. If it is not, like you have reached the end, so this is the list of length 3 and you are in the middle. and there is nothing to the right and nothing to the left, which is equal to the element. So in that case, you will just raise a message that the element is not in the list. Okay, so this is the very basis of binary search problem. So in this case, in the case of dictionary, we were just randomly going on to one location and then reducing the search space. In case of binary search, you divide it into half and then see if the element is less than or greater than, and then you focus on the remaining part of the list. Then you divide it again into half and then focus whether the element is to the right or to the left of the list, and then you focus on that particular part and so on till the time you end up being on one single element. And then if that is not equal to the element you're looking for, then you declare that the element doesn't exist, else you'll find out that element. So there is a concept of time complexity in computer science. So if you go on to this linear search, uh, even if it is sorted, so you will have to go on every element in the worst case till the end. However, so that will be like that is called like the complexity is like big O of n, if you would have seen such kind of notation. However, in this case, you are dividing it uh, into half every single time. So in this case, the runtime complexity of this is log n, where n is the length of the array or list, which is less than n. Sorry. So this searching algorithm, binary search algorithm, is faster compared to the linear search algorithm. Even but the disadvantage or the requirement for binary search algorithm is that the array should be in sorted order. Yeah. Yes, so that is the major drawback of the binary search algorithm, that it expects the list to be in sorted order. So you'll have to first get the list in sorted order and then perform the search operation on. Okay, so I hope the binary search is clear to everyone. Yeah, so I don't think so. There is any time left for the questions, but there are some questions in this. These are some questions from the previous session. And there might be some more questions on, uh, uh, the, yeah, so this was one of the questions. Binary search can be applied on only sorted list. There is something else actually, like we have not discussed this speech recognition library, but I'll urge you all to go through it. So if time permits, we'll see it in the next session. So there is a library called speech recognition in Python, which you can use to you know, convert an audio file containing some speech to the corresponding text. So you can look into the detail online. Like just search speech recognition library in Python. You'll get tutorials online. We'll discuss it in next uh, class as well. So you can look into these problems. I'll upload this PDF into the folder. And yeah, so that's it about today's class. So are there any queries? Yeah, so the answer over here is D. Yeah, but there are many more questions. We'll have one session in which we will solve only questions, and then through questions we'll clarify the concepts. So yeah, in these sessions I really am trying to just clarify your concepts first, so that you will be able to solve your assignments. Although I may not be able to cover all the concepts because it's not sufficient, like 2 hours are not sufficient to cover all the concepts. But yeah, I try my best. And I hope these sessions are useful and you're learning something from these sessions. So thank you everyone for joining, and apologies for any mistakes during the sessions. So please feel free to correct me if I am making any mistakes, so you can point it out. I'm also learning with you all. So yeah, thank you. Thank you everyone. So whatever queries you may have, we can discuss them later. By the way, before we end this session, I think in next week as well, I'll have to postpone it to the upcoming week. So I'll let you know through the NPTEL team. So please keep checking email in case the schedule gets changed. So it might happen, the schedule, like the session might happen on either the next Monday, uh, the Monday after this week, and then or Tuesday. So it will happen on one of these 2 days. So please keep checking your email, and yeah, look forward to seeing you again.
Okay, sir.
Thank
Sir,
you for
I have a
joining.
quick question. Hello.
I'll end the session now. Thank you.
Okay, sir.